Apart from dynamically executing a system, there are other ways we can test requirements, designs, and program code. We have looked at reviews, now we will look at static analysis, which examines the software artifacts without executing them. Static analysis is the analysis of software artifacts, for instance requirements or code, carried out without execution of these software artifacts. It usually implies the usage of tools that automatically scan software artifacts to find out if they contain defects. Static analysis tools analyze program code, for instance control flow and data flow, as well as generated output, for instance logs. Like reviews, but unlike dynamic testing, static analysis looks for defects without executing the software being examined by the tool. It can locate defects that are hard to find in dynamic testing. What is the value of static analysis? It allows an early detection of defects prior to test execution. It also improves the early warning about suspicious code or aspects of the code or design. For instance, if it is too complex, it allows for an improved identification of defects that aren't easily found by dynamic testing. For instance, development standard breaches, detecting dependencies and inconsistencies in software models that were either incorrect or unknown before static analysis was carried out. It also allows us to have an improved maintainability of code and design and to reduce or to augment the prevention of defects. Typical defects found by static analysis tools include referencing a variable with an undefined value, for instance using a variable as part of a calculation before the variable has been given a value, inconsistent interfaces between modules and components, for instance module X requests 3 values from module Y which has only 2 outputs, variables that are never used. This is not strictly an error, but if a programmer declares a variable and does not use it, there is a chance that some intended part of the program has inadvertently been omitted. Unreachable, or also known as that code, that means lines of code that cannot be executed because the logic of the program does not provide any path in which that code is included. Programming standard violations. If a standard, for instance, is to add comments only at the end of the piece of code, but there are notes throughout the entire code, this would be a violation of standards. Security vulnerabilities are also easily found, for instance, password structures that are not secure. And finally, syntax violations of code and software models, such as the incorrect use of the programming or modeling language. Just to reiterate, a variable is a name attached to a piece of memory in which the value of an item of data is stored. All variables in a component need to be defined in terms of size and format and given an initial value, even if it's zeros or blanks. If a variable has been used in a component but has not been previously defined, then it is known as an undeclared variable. If, on the other hand, a variable has been used in a component and has not been initialized, the results could be unpredictable. The use of static analysis tools are typically done by developers for checking against predefined rules or standards, and designers during software modeling. Compilers and IDEs typically offer some support for static analysis. They provide diagnostic information on where variables are defined and used, for instance, and also other support in the calculation of metrics. Static analysis tools can depict the logic structure of code and identify all different routes that could be taken through code when it is dynamically executed. They can also indicate how complex the code is. The more logic in code, the greater the possibility of mistakes being made in the code and the more ways it needs to be tested. Some key points to take away. Software work products can be examined and assessed by the different static techniques, difference between static and dynamic techniques considering objectives, types of defects to be identified, and the role of those techniques within the software development lifecycle. A typical formal review implies phases, roles, and responsibilities. There are differences between different types of reviews. So, informal review is different from a technical review, that is different from a walkthrough and an inspection. There are typical defects and errors that can be easily identified by static analysis. Thank you for watching.